Unit 3, Revision Gold, question 6 is a Markov chain question. We are given the transition matrix P and we are given the initial state. So for A, we need to find x1. So we're going to do that as xo times P. Now it's asked that we do this tech-free. 1, 0 times 0.4, 0.6, 0.7, 0.3. Now remembering, I'm going to go, this is A, remembering this is a 1 times 2, and this is a 2 times 2. What we are going to get, it's going to give us a 1 times 2. So it's going to give us this style of matrix. So we go across the row and down the column. So it's going to be 1 times 0.4 plus 0 times 0.7. Over here, 1 times 0.6 plus 0 times 0.3. So obviously that's going to be 0.4, 0.6 will be what x1 is. Now B, it says to calculate x2, which we can do that by doing, if we're doing tech-free still, we're just going to go x1 times P. 0.4, 0.6 times 0.4, 0.6, 0.7, 0.3. Again, 1 by 2 by 2 by 2 gives the 1 by 2. So we're going to have 0.4 times 0.4 plus 0.6 times 0.7. That's going across and down. 0.4, 0.4, 0.6, 0.7. Our second one will be 0.4 times 0.6 plus 0.6 times 0.3. So we always go across and down. That one and that one, then that one and that one. Your tech-free, this is a little bit tricky. It's going to be 1 point, no, what's that? That's going to be 0.4 times 0.4 is 16. 2 to 0.16 plus 0.42, 0.24 plus 0.18, 0.58, 0.24 and 18. That'll be 42, won't it? 0.42. It's doing a little bit of it, math in our head. Now for C, x10, we're not going to do this tech-free. We're going to go times P to the 10. So on my trusty calculator, I've got a 1 by 2. 1 by 2 is 1, 0. Actually, I should do that. 1, 0 times 0.4, 0.6, 0.7, 0.3 to the 10th times a 3 by, delete, times a 2 by 2. 0.4, 0.6, 0.7, 3. To the power of 10. Execute, and we are going to get 0.538, 0.462. Probably round that 5 up. And that's how we do for 10. Now, the last question, part D, asks us about the stable state. Stable state vector. Okay. And what is we want as a stable state? So let's put P to 100. So I'm going to go back over here, and put in, a bit closer, 0.4, 0.6, 0.7, 3. I am going to put that to the power of 100. Notice now I get doubled up, 0.58385, 0.5385, 0.4615, 0.4615. So my stable state, XS, is 0.5385, 0.4615. That is my stable state. I just need to take one of my rows. Why stable state is important and what its special value is you take your stable state and you times it by P, you're still going to get your stable state. Okay, so what that means is, let's go back over here. Let's do my stable state, which is a 1 by 2, and I go 0.5385, 0.4615, and I times it by a 2 by 2, and it's 0.4, 0.6, 0.7, 0.3, and notice it gives you the same, doesn't it? Da, 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 da. Because it's stable and it gives you the same. And that's that question.